Your title above this would have said, finding the definite integral using substitution. And then two methods are possible, because notation could be a problem. So I hope you see that this is a nice substitution. Here's the function inside, there's its derivative. So it's going to make sense to let u equal 5 minus x squared, and then to get the 2x dx by itself, we actually would have to substitute in a negative du. And here you have choice, okay? I will show you in red here the number one mistake that gets done next. And you see if you can find the mistake. So I'm gonna substitute in. I'm gonna do it in red. 1, 2. 5 minus x squared. That was my u, so I got u to the 4, and then the 2x dx. That's minus du. I'm gonna put it in brackets so it doesn't look like subtracting. And so I could put that negative. I could put that negative out in front. I could, yeah, why don't I just put that negative out in front? U to the 4 du. And I've made a mistake. And it's very, very hard to see. All right?
If you put the negative out front, you have to flip the 1 and 2.
Well, if I flip the 1 and the 2, that makes a negative come out in front. I just took the negative that was a constant and brought it out in front. In fact, if I erase this last line, I've already made the mistake. And it's very hard to see, because I haven't taught it to you yet. So don't feel bad whatsoever.
You didn't change the bounds of the integral.
So when we change, the x was going from 1 to 2. In the original question, it's saying when x goes from 1 to 2, do this integral. But as soon as I change u to 5 minus x squared, that means when x is 1, then u would be 4. Does that make sense? And when x is equal to 2, u is equal to 1. So if I was writing this correctly, I have to change the 1 to a 4 and the 2 to a 1. And then I wouldn't lose marks. So now we have two choices for evaluating this. Okay? How do we avoid this error? Method 1 for avoiding the error is don't write the bounds at all. If I don't write the bounds at all, I can do my substitution, no problem. And when I do my substitution with no bounds, I would have to write a plus c. And then I could substitute back and then start again with my bounds and say, I figured out the integral of this was negative 5 minus x squared over 5 from 1 to 2. Okay? So I ignored the bounds and just integrated to get the answer. And then I started again with the bounds and didn't show any u work to get to the next part, fundamental theorem of calculus part 2. And from this, we could plug in and evaluate 1023 over 5. I personally like changing the bounds. So I'm going to tell you that I like method 2. So method 1, you have to integrate without writing the numbers, and that's going to be really hard for you. Because you see that, like in math, whatever you saw on the line before, you're so trained to make sure you don't miss anything, and so to purposely not write something feels a little bit wrong. So now with bounds, I tend to say I like what I did here in purple. I do my substitution, and I also say I need to do my substitution with my bounds. So this should get erased. Well, I'll erase it all because we'll see it in a second here. So I change the bounds, which we did up there in purple, and now I can write my integral. No, I'm going to write it. I'm going to scroll this. No, I didn't scroll. I'm going to take one extra step and write the integral from 4 to 1 of negative u to the 4. I just put that negative right in the front so it didn't think it was a subtracting du. So when I do my substitution in, I've changed my bounds. And then when I integrate, my bounds are here and I do not need to substitute back. This is really nice. Because this just says, you need to plug in 4, you need to plug in 1. That'll give me negative 1/5 minus a negative, which will be plus 1,024 over 5. Same answer. Method 2, I think, is so much less work. But when you do a substitution, you have to remember then you also have to do a substitution for the bounds. So for this next example, are you okay if I just show you? You need to go back. I went too fast. Yes. Okay. Is that enough?
Can you do the other method?
Do I even need a substitution in this one? I don't think so. But let's say you do, because sometimes this is just a simple chain rule. You could have done the integral and then undone that simple chain rule by dividing by 3. However, some people really start to like substitution, and even with simple chain rules, they set things up. Now, what happens to your bounds? Instead of going from 0 to pi over 2, if we now plug in, we will go from 0 to 3 pi over 2. And I might even then do my substitution. You okay if I put that 1/3 in the front? Because it's 1/3 du. And now we integrate. Integral of sine is negative cos. So we get negative 1/3 cos u from 0 to 3 pi over 2. And you just get 1/3. And you don't even have to substitute back. All right, you want to try the next 2 on your own, and I'll put the answers up in a bit. See if you're on the right track. And then I I guess one of the things I would have written, I would write in this second one. After I change the bounds, I would rewrite it with the bounds and my substitution built in. So the negative 1/2 can come out in front, and I would have the square root of u du. Now when you integrate this, this is u to the half. Add 1 to the exponent, you get u to the 3/2. Dividing by 3/2, multiply by the reciprocal, will cancel out the 2's, and you'll get the negative 1/3. But I would probably, if I was doing my own work, I would probably have a step where I kept this as negative 1/2, all divided by 3/2 like that, and then simplify after. Because otherwise you're like, how did that happen? Is that a typo? No. It just becomes 1/3. You can plug it in and get your answer. Yes.
Is the integral 4 to 0 or 0 to 4? You have it written.
I wrote it. I saw my bounds
Like
there.
I think the black one's backwards.
Yeah, the black one. I just looked at the numbers, and you get so used to writing. You get so used to writing from small to big, but you have to make sure when you look at what was on the bottom was the 0. When I plugged in the 0, I got the 4, so that has to be on the bottom. And the last one, see how you did on the last one. So I would, again, once I find my new bounds, I would probably take the time to write. So I plugged in 0, that became a 1. I plugged in pi over 2, that became a 4. Even the numbers seem nicer to work with. And then I am left with 1 over the square root of u du, which becomes u to the negative 1/2. I might even write that out. Rewrite this as u to the negative 1/2 du. Add 1 to the exponent, we get u to the 1/2, divided by 1/2. That's how I got the 2 out in front. Yeah, I kind of like just writing this step here. That's a lot of mental math to manipulate and change. I'd recommend for you guys to show a little bit more work there. So I would probably, my next step before this one would probably look like this. Add 1 to the exponent and divide. And if you want to change it back to the square root, you can. Or you can keep it to the 1/2, but it becomes really easy mental math. I don't even want to show the other side. Can you imagine doing everything with all those sines and coses? No. Why? Okay, I'm going to stop.